Now we're going to talk about imaginary and complex numbers. Okay, so where in the world do what we call imaginary numbers come from? Well, kind of in, I guess, classes that you would have taken before today, you would have maybe seen something like this, where you were taking the square root of maybe like a negative 25. Okay, so when you did this before, you might have said something like, there is not a number that we know of that if we take it, because remember, when you're square rooting something, you're kind of asking yourself, what number, when I take it times itself, will give you this number? And there's not a real number that we know of that does that, that will give me a negative 25, okay? So in classes before this, we would usually write down that it didn't have a real solution, and that's true. There's not a real number that would work in that problem, okay? But there is what's called an imaginary number that would work, okay? So imaginary numbers and complex numbers come around whenever you end up with a negative number under the radical, okay? So that's actually what we're talking about today, is how to simplify stuff whenever you have imaginary numbers in the problem, okay? So let's start by talking about what is an imaginary number, and it actually has to do with the letter I, okay? So I'm going to show you where that comes into play in a second. But I, anytime you see that letter, this is actually an imaginary number that will come about. So I'm just going to put number that comes when you take the square root of a negative number. And this is actually what you write whenever you take the square root of that negative. And that's actually what pulls the negative out from under the root, okay? So I'm going to show you how that works, okay? The reason why this works is because I is actually the same thing as the square root of negative 1, okay? So if we were to actually simplify that using this, just like what we did in other problems, if there's kind of multiple things underneath the radical, what we would typically do is we would break it up. So I'm actually going to break that negative away from the 25, so that would have to be like written like a negative 1. And then I'd take that 25 and I would kind of separate it and take the square root of 25. And so if you were kind of simplifying it like this, well, the square root of negative 1 is the imaginary number, and so we write it as an I. So that would end up being I. So I'm just going to write it underneath, or I guess to the side of it. So that would end up equaling I. And then you could do this one like normal. So the square root of 25 would end up being 5, okay? So then to write your answer, just like you did before, you would put these two kind of together. And so you always put the number up front, so that would be 5, and then you put the I right behind it. So the answer to this question, if we took the square root of negative 25, it would equal 5i, okay? So that is kind of how you simplify radicals using that imaginary number. And so anytime you end up with a negative under a radical, to pull it out, you actually write that as an I, okay? So let's do a couple more examples like this, like with just simplifying radicals, and then we'll kind of start talking about a little bit more about that imaginary number, and we'll lead to what's called complex numbers, okay? So let's do a couple more examples here, all right? So examples. So we'll just put a number 1 since this is the first one here. So what if we had the square root of negative 4? Well, notice, because it has a negative number under the radical, we know we're going to have an I. So you split it up. So you're going to split it up, take the negative out, and it could be written as a negative 1. And then you split that up from the 4. And then you just simplify it. So that will end up being the same thing as I. So that will be written as I. And then the square root of 4 is 2. So then you put it together. So the square root of negative 4 would be 2i. Okay, so I is kind of like a placeholder for that negative that's under the radical. Okay, so what if we had something like this? What if you had the square root of negative 8? Okay, same thing as before. You got to take the negative out, so you're going to split that up. So you write it as a square root of negative 1, and then you take the square root of 8. So this will be your I, so that's part of your answer. And then this one, notice that one's not a perfect square. So when it's not a perfect square, you break it up into 2 radicals, and then you figure, okay, what is the biggest perfect square that goes into it? And then what times that will give you 8. So if I kind of think through it, okay, 1's a perfect square, 4's a perfect square, 9's a perfect square, and 9's bigger than that. So if we think through all our perfect squares, we'll realize that 4 goes into it, and it goes 2 times. So if I take 2 times 4, I get 8. Okay, then you simplify. Square root of 4 is 2, and then my square root 2 just comes down. So now how do you take this and write your answer? Well, when we did kind of simplifying radicals before, if you remember, all the numbers that are outside the radical go together. So you're going to put your 2 and your I together, kind of like, I guess, that last one worked. So you have 2, and then you put your I right after it. And then whatever's underneath the radical, where the square root, goes last. So the way that you would write that would be 2I square root 2. Okay? So let's do another one. What if you had the square root of negative 10? Okay, notice there's a negative under the radical, so we're going to split that up. So we got the square root, and we pull out our negative 1, and then we have the square root of 10. Okay, so the square root of negative 1 is I, and then the square root of 10, well, that's not a perfect square, but if I kind of think through it, there isn't a perfect square that goes evenly into it other than 1. So that means that that one won't necessarily break down like our last one did. Okay, so that's kind of, I guess, the other part of your answer. So this is outside the radical, so you put that first, and then whatever's underneath the radical you keep under there, and then you write it second. So that would actually be the simplest form of that expression, or that radical. Okay, so then what if we had the square root of negative 32? Same story. You break it up. You got the square root of negative 1, and then the square root of 32. Then you simplify each one. So we've already figured out that's the same thing as I. That's your imaginary number. And then that's not a perfect square, so you see if you can break it up. Is there a perfect square that goes into it? So if you kind of list out your perfect squares, we got 1, 4, 9, 16, 25, so on and so forth. And we're looking for the biggest one that evenly goes into that. So if you start kind of dividing those number, or 32 by those numbers, you'll figure out that 16 goes into it. So you're going to break it down into the square root of 16, and then what number times that gives you 32? Well, if you take 2 times that, you'll get 32, and then you simplify. So the square root of 16 is 4, and then the square root of 2 doesn't simplify, so it just comes down. Then you put everything together. So you've got the 4 and the I on the outside, so you got 4I, and then that square root of 2 just comes down, or excuse me, it comes up, and you put it behind the 4 and the I. So there you go. Okay, so let's do one more, because we haven't done one with a variable yet. So let's do one with a variable. Okay, so what if we had something like the square root of negative 36 x to the 5th? Okay, so just like what we did with the other problems, when we were simplifying, you break it into pieces. So you've got the negative, you've got the 36, and then you have the x to the 5th. So you actually have to break this into 3 things. So you got the negative 1 for the negative, you've got the square root of 36, and then you have that square root of x to the 5th. Okay, so that's going to be I. And then the square root of 36, that is a perfect square. So If I take the square root of 36, I get 6, so we get 6 there. And then x to the 5th, remember you can write it out, so you could write x times itself 5 times. That's one way of thinking about it. Or you could take the power over the root, so it'd be like 5 over 2. Either way, and you'll be able to get your answer. But if we're writing it out, then the square root, it's a square root, so that means you're circling groups of 2. So however many groups of 2 you can make would be how many x's come out. And so notice I can make 2 groups of 2. So an x to the 2nd would come out because there's 2 groups in there. And then however many is left over that you couldn't make a group with stays underneath. Okay, so there is my answer there. Okay. Now, to put it all together, all your outside things go together. So you always put the number first. So you got 6. Then you'll put your x squared. And then your I. So your I goes last. And then anything that's underneath the radical, you put at the very end. So your answer for this problem would be 6x squared I, and then square root of x. Okay, so that is how you write the simplest radical form when you have imaginary numbers. Okay, so let's talk a little bit more about these imaginary numbers for a second, because imaginary numbers, yes, it is a way to kind of get your negative from underneath the radical, but there are some kind of peculiar things with this. So now we're going to talk about that, all right? So I'm going to flip it over, and we are going to talk about some things that you need to know just about imaginary numbers in general, okay? So if we look at just I, so think about what I is equal to. I is equal to the square root of -1, okay? What happens if I look and I figure, okay, what would I squared equal? Well, there's a couple ways that you can think about that. What you're essentially doing is you are taking the I, which is the square root of -1, and you're essentially taking it times itself twice. So that's like I times I. So it could also be, you could think of it as like the square root of -1 times the square root of -1. Or you could just simply think, okay, I'm taking this, because that's the same thing as I, and I'm squaring it. And so if you kind of think about what would that equal, well, think about what we talked about the other day. The square root and squaring something are opposites. So what actually happens here when you square your square root is those cancel. So if I take I and I square it, it actually ends up being -1. Okay, well then what if I take I and I take it to the 3rd power? That means I'm taking it times itself 3 times. Okay, well, if you kind of think through, if we took it times itself twice, we ended up getting -1. So what if we took it and put another I with it? So that would be like what we got here times another I. Well, that would essentially be -1 times whatever I is. Okay, well, that would end up being just -I. Okay, so what if we kept taking this and multiplying it by another I? Well, that would be I to the 4th. So what happens if we take I to the 4th? So you could just take this and multiply it times I again. Or, and like another way of thinking about this is this would be the same thing as I squared times I squared. So think about what I squared is. I squared is actually -1, so that would be -1 times -1. So then what's -1 times -1? Well, you get 1. Okay, well, what if we keep going? Well, what's I to the 5th going to be then? Well, wouldn't you just take what we got and multiply it times another I? So that would essentially be 1 times I. So you end up with I, which is, isn't that where we started? So then think about, if I take it times another I, think about what that would be. Well, we would just take what we got here and multiply it times I again. So then what's I times I? that would be the same thing as I squared. So that would end up being -1. So if I kept going and I did like I to the 7th, well, think about what that's similar to. That would actually be as if I'm taking the -1 times I again. So that would actually match up with what we got up here. So the thing I want you to realize about imaginary numbers is if you start kind of taking them times itself, it kind of forms a pattern. And at a certain point, it repeats itself. So notice after we took it times itself and took it to like the 4th power, we ended up with 1. So then it kind of starts over again. You have I, and then -1, and then -I, and then it would be 1, and so on and so forth. So if you kind of recognize that, you can, if they give you problems like this, you can kind of figure it out. Okay? So the thing I need you to know about imaginary numbers is they kind of form a cyclical pattern. They kind of go in a circle whenever you're taking it to a certain power. Okay? So now, where do complex numbers come into play here? Well, complex numbers is actually a way that you write imaginary numbers whenever you have them kind of mixed up with real numbers, okay? So a complex number is kind of like you have a mix of a real number and an imaginary number too. So it looks like this. It's a number in the form of, you have a number plus another number, and that's the one that has the I with it, okay? And so these two, the A and the B, are going to be real numbers, okay? And then because the I is with the B, then that makes it kind of like part of the imaginary part. So A and B are real numbers. Okay, and then the I is the imaginary number. All right, so where does this come into play? Well, just to kind of give you an example, if you had like the number 2 plus 3i, that is a complex number, because notice you got 2 and 3, those are real numbers, and then you have your imaginary number. So what we're going to practice is kind of taking an example and simplifying it and writing it in this form. So these would look something like this. You'd have like 3 plus the square root of -25. Okay, notice we do have a little simplifying to do, but then we're going to put it in that form. Okay, that doesn't have to be simplified, so you just bring it down. But then think about what that would equal. Well, you've got a negative underneath there, so that means you've got an I. And then what is the square root of 25? Well, it'd be 5. So it would be 5, and then the I would go behind it. And notice it's already in this form. You've got a number, a plus or minus. That can be a plus or a minus. And then you have a number I. So there is your complex number. Okay, so what if you had something like this? Okay, well, if you had to put it written as a complex number, you have to simplify the radical first. So let's figure out what that is. So break it up. You got the square root of -1, and then you have the square root of 8. So the square root of -1 ends up being your I. So that's your imaginary number. And then the square root of 8, that actually breaks down because that's not a perfect square. So what is the biggest perfect square that goes into it? Well, it'd be 4. And then 4 times what gives you that? It'd be 2. Okay, and then so that would end up being 2, and then your square root 2 comes down. So that is kind of like the part that's going to be part of the imaginary part. So remember, you put your 2, and then the I, and then the square root of 2. So there's that. And now we had this 9 kind of hanging out. So this ended up being 2I square root 2, and then you're going to bring your plus 9 down. Now, does it look like that? Well, to look like this, you have to have the I part in the back side, okay, or behind. So what we have to do is take this and write it behind the 9, which is pretty easy. So you take your 9 up front, and it's a positive 9, so we just write it as 9. And then this goes behind it, and it's positive, so you have to put plus, and it'd be 2I square root 2. So here is your complex number. You've got your real numbers, and then you have your imaginary part. So there you go.